Hello, everyone, and thanks again for joining today's webinar. Just a few quick housekeeping things. Today's webinar is being recorded, and a link to the webinar will be emailed to all registrants shortly after the webinar. Make sure that if you have any questions, to please ask them in the questions panel in the GoToWebinar panel. Also, as another reminder, 10 attendees of this webinar will be randomly chosen to receive the full Docker up and running book. But for those that don't, can still download the preview edition, which we will link in the chat window. Now I am going to pass it off to Andrew Marshall. Take it away, Andrew.
Thanks, Peter. My name is Andrew Marshall, and I am a Senior Product Marketing Manager here at New Relic, working on our infrastructure team. Work very closely with Adam Larson, who is to my right. Adam is a software engineering team manager, and he is actually the person who built our Docker monitoring. So he'll be able to dig into that. We'll do about 50 minutes of presentation today, followed by 10 minutes of Q&A, where we'll tackle any questions you guys have on what is Docker, specifically Docker monitoring or any of our other solutions. We'll answer any and all questions other than questions about why Adam's head is tilted at a 45-degree angle at all times. He's very sensitive about that, so we'll just pass right over that. So by the end of the hour, we hope that you'll have a really good understanding of Docker, the various use cases of Docker, how Docker is evolving and people are doing new and cool things with it. Specifically, we'll dig into Docker monitoring and how we allow you to monitor your applications that live within the containers. Adam will do that through a Docker demo. And then we'll cover the next steps and show you just kind of how easy it is to get going monitoring your Docker containers. First, I'll cover a couple things on the New Relic side. So we have a number of core philosophies, one of which is that every business, no matter what it is a software business. So the time when your application was kind of a niche use case or only a certain subset of customers were using it, or even it being kind of the front door to your company is pretty much over. Customers really demand a first-class experience when they use your application, and therefore, making sure it's running optimally with no mistakes is absolutely critical to pretty much any business, which is where New Relic comes in. So we offer a number of products that gather real-time metrics from live production software. And we then analyze those results so that you can make appropriate business decisions kind of quickly and also very easily. Probably more important than that is that New Relic captures these data conversations that your customers are having with your business software. And these interactions actually formulate a story that everyone in the company can easily kind of take a look at. So no matter what user is using the application performance monitoring software within your company, they can make any business decisions they need based off a common set of data. So it doesn't matter who is actually using this data that New Relic provides, whether you're on the business side, perhaps you're more concerned about the high-end operation of the company and how we're making business decisions accordingly, or perhaps you're on the customer end of things and your concern is really how the customer's experience with the application is performing, or as I suspect many or most of you guys are, really concerned about how the application itself is performing. Our suite of products provide a single set of data that everyone can use to analyze how the application is performing and really kind of avoid any finger pointing or data misalignment in that regard. So New Relic offers a SaaS-based platform that includes a number of different individual products. APM servers are really what we're talking about today. We'll touch on that here in a second, but I did want to do a real quick overview of some of the other products and how they help complete the APM picture. We have New Relic plugins, which is a set of plugins that allows you to extend your visibility of application performance into all sorts of different realms, so databases, AWS, other kind of ancillary parts of your business. And that's set up in a way that you can kind of easily either reuse plugins that are out there or even create your own. New Relic Mobile and Browser, as the names imply, extend our monitoring into the mobile space, so you can see how a customer's experience is operating based off of a mobile app. Browser, from a similar perspective, looks at things through the customer's browser experience. So it's a very, very good customer-centric way to take a look at how applications are performing. We have New Relic Synthetics, which allows you to test your applications through simulations of the software. And finally, we have our Insights product, which allows you to dive very deep into the business data and ask very specific questions about how things are performing and kind of customize your experience there. And that's a very powerful tool that kind of sits on top of all these products. So APM, in a nutshell, is our flagship product. The one kind of key takeaway with this is it is just dead simple to set up and use. So customers really love APM because within a few minutes, you're up and running. You're seeing a visual representation of how your application is performing with all the associated metrics very quickly. Obviously, we support the most popular coding languages in over 70 framework as well, and it really gives you a good idea of how your business is working from the application perspective. Servers, New Relic Servers is the product that our Docker monitoring lives inside. New Relic Servers is a free product. Therefore, Docker monitoring from New Relic is also free. So we'll touch a little bit on how it works within the demo, but in a nutshell, New Relic Servers really helps complete the APM picture by attaching that infrastructure layer to your monitoring of your applications. And I guess the kind of key takeaway here is that you want to be able to find out if something's wrong. Is it your application that's performing badly or poorly, or is it the infrastructure? And New Relic Servers, among many other things, allows you to dig into CPU usage, memory, network, disk I/O, etc., and actually find out exactly how your infrastructure is performing. It allows you to dig into things like the individual process, so that you can find out which of these processes are consuming more than their fair share of resources. And you can do a number of different things that allow you to see how your infrastructure is performing, including and introducing Docker monitoring. And Docker monitoring is our kind of new addition to the New Relic Server stack. And with that, I'd like to pass the mic to Adam Larson, who will be walking us through exactly what Docker monitoring looks like.
I wish there was a physical mic for you to pass to me right now.
So do I.
All right, hey everybody. So as Andrew mentioned, I'm Adam Larson. I'm the engineering manager that primarily focused on the Docker integrations here at New Relic. And the most important thing to take away from that sentence specifically is that I'm an engineer who had to work in PowerPoint following up a marketing guy. So expect a severe degradation in slide quality coming up here. So let's kind of get into this. So first off, like Docker is a really big thing. There's a lot of different analogies and content out there explaining what Docker is and what Docker does. Andrew actually made me promise not to use any shipping containers or Docker pants jokes in this speech. So kind of some of the core analogies weren't available to me. And when I looked at the other ones, none of them really kind of suited my needs. Again, being an engineer, I just decided to kind of throw that all away and start from scratch. So this is kind of my unique take on what Docker is. I'm going to pivot it around what Docker means to your organization and you as an individual, depending on your different role, as well as kind of like where a lot of the hype is probably coming from in the industry right now surrounding Docker. So getting started. In the beginning, in the early days of software development, you had a box. And this was a very special box. This box, like you put a label on it, you always knew where it was, you didn't let it get wet, like you made sure that it didn't get crushed. And like any other box, this box was special not because of it being a box or anything about the attributes of that boxiness. It was special because what you put inside of it. And this obviously equates to a server. So this metaphorical box in the old world was a server, and the very special things that you put inside of this box were your applications. Like Andrew kind of already alluded to, like applications are kind of a core tenet of most businesses these days, so it matters that they actually run. So you have your application in a box, and I'm just going to take you through kind of like what the old world looked like. You put the application on the box, and it would actually be the developer would write the application, and then an ops guy would come in and he'd actually put it on the server. But before he could actually put it on the server, he had to get all the library dependencies kind of like on the server as well. So like, he had to make sure that he set everything up there. And then those dependencies would probably have a dependency of their own. So like he'd get all the kind of environment set up properly. Application would be running, server stable, everything's great, the world's a bright shiny place. If the call was not muted right now and the attendees could speak, I assume there would be a lot of people actually just swearing right now and calling me a liar, because the reality is this is never what software development looked like. This is kind of the very academic view of what we hoped it would look like, but the reality was a little bit closer to this. You still have the same server, nothing changes there. You have your application, you get your dependencies on the server. But then, like servers are expensive, like this is a very special box, as you remember. So like, there's a lot of extra room on it. You want to be able to get kind of all that you can out of an individual server. So you add your second application. And your second application maybe has a dependency on a dependency that was already on the machine. So that's kind of easy for the ops people to manage. But then there's some new dependencies that it brings in on its own. And those dependencies might have some dependencies on some of App 1's dependencies. And that dependency, or you may have had some dependency during development time that you added that the ops people put out there that you removed and it just got forgotten about. So pretty quickly you see how this problem spiders out. This is just, like some boxes and lines. You can see how complex it is with just two applications in the, kind of ethereal sense. Imagine actually having to manage this. So the reality is your very special box looked probably a lot closer to this. Assume that the things inside of there are actually important because you actually have to dig in there and find things periodically. But anytime that you have to go in there, it's just a nightmare to deal with. Like you end up throwing a bunch of stuff away. You accidentally throw something away that you didn't mean to. You got to dig through the trash to find that. There's just a lot of problems. There's actually a term for anybody who's interested in kind of reading about this more called Dependency Hell that speaks about this exact problem. So this is actually a picture from a real data center. You can kind of see how the analogy works really well here. You can't actually see it, but there's an IT guy crying somewhere in the background. I know that because in most data centers in the world, there's an IT guy crying somewhere because managing things, finding what you need, making sure that everything's stable is just a really tough task. And like most businesses that I know of don't function off of just one server, so that problem compounds really quickly. But we're a very resilient industry. Like we find a problem, we're all problem solvers at heart. So we kind of came up with our first iteration of a solution here, which was the introduction of virtual machines. So the way a virtual machine works, we start off with the exact same server that you've always had. Nothing changes in terms of hardware. But instead of putting that application directly on the server, you basically partition a virtual server. So you basically you emulate the CPU and the memory and everything that makes that server what it is, and you put the application inside of this kind of smaller box inside of your bigger box, and that isolates things. So you can kind of see App 1 and App 2 are now kind of completely separated from one another. They can manage their dependencies completely on their own. So again, bright shiny world. Why are we even having this conversation? Obviously, because VMs didn't solve all of the problems. They did make the world a lot better, but one of the kind of biggest downsides of virtual machines is that they're actually virtualizing an entire physical server. So they're actually they're pretending that there's a software CPU, they're keeping track of the ticks, the memory, all that. So they're very, very heavy and cumbersome. So in general, your box kind of looks like this. You got a smaller box inside of it, but that box is still basically the same box filled with a bunch of crap. And you can only fit so many of them on there on an individual machine because they're very resource intensive. One of the other big things about VMs, it's not really a downside, it's just kind of a lingering problem, is that VMs are still very much like puppies. And I know a lot of people have probably already heard the puppies and cattle analogy. I was going to put a whole slide to kind of speak to it because it's a really important shift that's happening in the industry right now. But I've realized that most people actually don't like the puppies and cattle analogy, so I decided I'm just going to speak to it really quickly here. So in the old world, like when I'm kind of talking about these very special boxes with names that you keep track of and you take care of, those are very much like pets. You know, like they get sick, you nurse them back to health. You genuinely kind of care about like making sure that they're always up and running, and you put a lot of investment into them, so you care about kind of maintaining them. In the new world, with horizontal scale and cloud compute and kind of things like Docker, the world's very much shifting more to a cattle view, which I again apologize for how crass this is, but in general, like if you're having a problem with a horizontally scaled application, like you don't actually want to nurse it back to health. Oftentimes, it's not even prudent for you to go in and do the investigations. It's usually just better to kind of shut that machine down and spin up a new one and kind of forget the problem ever happened because everything's kind of interchangeable now. Kind of moving on, this is just kind of derived from the first point here. VMs take a long time to start up and shut down. And in addition, they take a long time to set up and kind of manage as well. Like you're still dealing with a full machine, like getting it downloaded and set up, and all of your dependencies set up is still a pretty heavy problem for IT and ops. Very minor point here. They're not very portable. Yeah, you can kind of move them across machines, but again, just by the nature of how big they are, it's not a very convenient story comparable to something like Docker that we'll get into. So again, we still had the same problem, so we tried again. And this is kind of the current state of where industry is at right now for application deployments. And I guess we're not even really there yet. This is where we're kind of going. But Docker comes into the picture. And again, this is the exact same server that you've always had, so you don't have to buy new hardware. You're basically just kind of cutting up your pizza in a different way. So the way that this Docker world works with your server is that instead of a virtual machine where you're virtualizing the whole thing or putting the application directly on the host, you have what's called a container. And that container, in most cases, I mean, it's fairly extensible. You can do a lot of different things here. But in general, that container corresponds to a single application. So you put application 1 in there, and I've actually drawn the dependencies more tightly coupled with application 1 because in general, while you're developing the application and you're creating this container, you're actually very cognizant of what specific dependencies that application needs to run and nothing else. So a container is basically, it's emulating an operating system, and it's basically just taking what the application needs to run, nothing else. So assuming that you're from a bare bones Linux VM, and then it's just running that application in isolation. So we'll kind of get into a few of the difference on the next slide here. But one of the big value props of Docker versus traditional virtualization is, they both solve the same problem of kind of application isolation and dependency separation, but you can fit a lot more Docker containers on an individual server, and again, the exact same server than you can VMs. And one of the really big benefits to that is that's huge cost savings. You can get way more capacity out of your existing hardware by switching to Docker than by managing things via VMs. And that's all kind of anecdotal, but a lot of people are saying that's why industries like banks that are traditionally very kind of stodgy and not really adopting the latest things very early on are really excited about Docker and actually kind of leading the charge with Docker because they see the immediate cost savings there. So just kind of another view about the previous couple slides. This is kind of what the world looks like with no virtualization. You have your hardware, the server itself, you have the operating system that runs on top of it, and then you have the different applications that are actually running on the operating system. With traditional VMs, you have your hardware, and then you have your virtualized hardware, which are basically all pretending that their own individual box, and you have operating systems running on each of those virtualized hardwares, and you have your applications running inside of those operating systems. And Docker virtualization, I put virtualization in quotes here because I know some of the real hardcore Docker people out there will outright tell me that Docker is not doing virtualization, which is very true, but just for the sake of analogy, I kept it. So you have your hardware and your operating system, exact same way they did in the no virtualization scenario, but now you have virtualized operating systems on top of that. which are basically just the deltas between the operating system that you're running on and the operating system that your application actually is going to be running on. So one quick thing to think about with Docker is that Docker is basically, or Docker containers are basically just processes running on your existing operating system inside of special little sandboxes. So a couple of the strengths of Docker. They're very small and lightweight. You know, I already hit on this. Like, you know, like they're extremely, like, it literally takes, you know, milliseconds to spin a Docker container up and to take it down. So it's like you can do a lot of, like, you know, really you can respond to load very quickly, and you can do a lot of interesting things that you traditionally couldn't with regular VMs. One of the other big strengths of Docker that I haven't really hit on yet is that it pushes dependency management up the stack to developers. So traditionally, like, you know, the deployment process and the dependency management process was kind of a black box to developers. You know, like they develop the application, they know they need this version of this library, but like the actual like process of like how that library gets on a host or like, you know, like what system library is up there was really kind of an ops job. With the way Docker works, like basically your container encapsulates everything it needs. It chooses what specific operating system it is. It has all the dependencies that your application uses, and it has your application itself. So the developer is basically cognizant of that entire chain, and it's basically a black box to ops now, or it can be in a lot of ways, like where the developer can basically say, hey, look, I've done all the work. Here's my container. Just make it run somewhere. One of the other benefits of Docker is that it works with your existing tooling. So like one of the things that makes adoption really hard for, you know, enterprise businesses, you know, like, you know, banks and kind of all of those like large scale, slower moving businesses is that it's hard to adopt new technology. You know, like you have people trained up on stuff, you have existing investment in tools. One of the really cool things about Docker is that it really integrates well and leverages a lot of the existing tools that a lot of people are already using to manage their application deployments. You know, things like Chef and Puppet and Vagrant and Ansible all work with Docker. So one of the other points that I think is really important about Docker that you know, like not everybody is aware of is that Docker actually leverages a lot of really old, well-established technologies. Like, you know, it sounds like it's the new kid on the block, and like, you know, like Docker is as a company, but Linux containerization has been around for, you know, a decade now, and it's actually something that's been vetted. I say by some big names here, like, you know, like Google is a huge proponent of, you know, like Linux containerization, and a lot of their infrastructure is already built up off of Linux containers. So like, you know, like when you're thinking about like the risk that you're taking on, or is this vetted well, or the security ramifications, you know, it's like a lot of those problems have actually like, you know, been addressed and are very hardened against already with Docker. Docker is just kind of a nice abstraction on top of those, you know, existing containerization mechanisms that already existed in the operating systems for a long time. So just really quickly, you know, like I want to go through what it means to all of you as individuals. You know, so for developers, first of all, like, you know, like the deployment is no longer a black box. You know, like developers actually have a sense of, you know, it's like exactly what their application looks like in production. And what that means is the whole "it works on my machine" tenet that's been around forever in our industry, where, you know, a developer is called by an ops guy and he's like, hey, your application's not working on my box, and the developer's like, hey, it's working fine on my machine. Like that problem kind of goes away, because the basically if it runs on the developer's box, it so like, you know, like I mentioned, like you can spin up a Docker container in a matter of milliseconds. So that means that you can do things with Docker that you couldn't do, like, you know, like with you know, traditional virtual machines. So it opens up a lot more kind of architectures for, like, you know, like dynamically scaling things, or for, you know, like addressing loads with, like, you know, individual sandboxes. So that's a huge win for developers. Ops, I'm actually going to take a really quick second to look at this picture, because probably 60% of the time that I spent preparing for this talk was me trying to find somebody who was smiling inside of a data center. This is as close as I could get. I think if you look closely, you can kind of see a dimple of a smile. Apparently, they're just not a very happy place to be. But hopefully it's getting a little bit easier with some of the pros that we're going through here. You know, easier portability and rollback. Like Docker containers, like in general, like there is no portability story, because you don't really care about where a Docker container is running. You basically just have a pool of Docker hosts, and you say, all right, like, you know, you use a tool like Mesos or Marathon, and you basically say, all right, just go distribute these containers somewhere. and you just care about like, it's like, is the application running? You don't care about like where specifically unless you're troubleshooting something. Like, there's no special machine or dependency setup that you need for Docker anymore. So it makes the job a lot easier because now they're just managing a cluster where kind of every application looks the exact same. Easier capacity planning, exact same thing. Like, you don't need dedicated hardware for every individual application that you're doing. Like, there's actually an example recently of like, I was spinning up a new project and I reached out to our IT organization. I said, hey, I need a server to do this. And they said, yeah, sure, it's going to be about 6 weeks for us to get that new server in our data center. And like with Docker, it's like that server's already out there. It's just, here's my new container, go deploy it on the server. So it allows a lot more agility where like you can get to market a lot faster. Developers can proof of concept things a lot faster. There's a lot of huge advantages in terms of capacity there. Patches are easier. Like this one's kind of up for debate a bit. But like in general, like it's like when you're patching machine, you're not worried about like it's like what version of what library is used by what application that's running on what host. It's basically just like like I have to upgrade Docker and make sure that all the applications are running on Docker. And ultimately, that all boils down to all of the existing tools that you have, all the existing servers that you have, all the existing kind of mechanisms that you have for managing them. Like, you get a lot more bang for your buck. You can get to market faster. You can manage things and get more things out of your existing hardware. There's one other subsection of people that I assume are on this call that I wanted to kind of reach out to directly. And I don't actually know too much about what the business does or like what their success metrics are, being from the engineering side. But like cost savings is a huge thing, time to market, all of those values equate to more Lamborghinis, more Mai Tais. In Andrew's case, more dress shirts to tuck into his khaki pants. Like, there's a lot of cost savings being on Docker. My wife actually told me to cut that joke. She said it's not going to be funny. So sorry, Tram. So now I want to get into kind of that's what Docker is. I want to talk about what we did for Docker specifically. And before I talk about what we did, I want to talk about what we didn't do. So we at New Relic we're very early adopters of Docker. It's like we run a lot of our workloads in production already. We have a lot of applications that are supported by Docker. So a lot of this was actually driven by necessity from our part. Like, it's like we were feeling a lot of pain with how do you monitor this thing? Like, it's like finding, kind of like when problems are troubleshooting problems, like all of these problems were real for us. So we were familiar with the landscape. We knew some of the open tools out there. We looked at, some of the other kind of options for Docker monitoring. And in general, what we saw was a lot of those other tools were basically just regurgitating the data that you get from the existing Docker APIs. Like when you install Docker on your machine, there's a set of APIs that you can use for monitoring. And basically all of the Docker monitoring tools that were out there were basically just taking that data verbatim and just shoving it up into, like the cloud or on some web interface, which, it's really impressive, and you could, get a lot of great insight into like, like what's going on where. But in general, it wasn't very actionable. Like we'd notice that, like, it's like we'd see container 1654693 is having a CPU spike up to 70%. But that GUID identifier really meant nothing to us. It's like you don't know, is that abnormal? What application is that supporting? Like, it's like, should I do something about that? Because there's no real context associated with that data. It's just kind of the raw data. So you're kind of forced to have like a bunch of logic in your head that says like, oh, like that container, let me log into the machine. All right, yeah, that represents this application. It was a pretty cumbersome story, and we didn't like that, and we didn't want to do the same thing. So kind of pivoting on to, with that, we defined kind of a core set of guiding principles that we wanted as part of our Docker monitoring solution. First off, we wanted to fix what was broken. Like we'll get into this one in a little bit here, and like broken's a very strong word, but Docker, like with a lot of the other solutions, like they were kind of just adding a little shim on the side and saying like, hey, install this additional thing, and now you can see these additional Docker metrics. But their core products like still were suffering in the same ways that ours were when Docker was a part of your app stack. So we wanted to make Docker feel like a first-class entity inside of New Relic, basically a seamless experience, because we realized a lot of people don't care about Docker specifically and monitoring Docker. They care about, is my application doing okay, and is Docker facilitating like that happening? We wanted to prioritize useful information over impressive information. So in general, we didn't want like we didn't want people to be overwhelmed by the data that we have. Like, there's a lot of stuff that you can pull out from Docker, and like we wanted the data that actually helps you solve problems that you're going to encounter in the wild, as opposed to just throwing the fire hose at you. We didn't want to expect a PhD in sleuthing. So what I mean by that is essentially we don't want every single customer to like have to log into the Docker machine, figure out what application is represented by what random GUID, then log into New Relic and see like, oh, this GUID's having a problem, and then log into some other tool. Like, we wanted New Relic to be kind of a one-stop shop for solving the common problems that you're going to have with application deployments for Docker. And finally, we wanted to optimize our solution for now because later isn't clear. So Docker is a very emerging technology. We're seeing a lot of really interesting use cases with Docker, but predominantly we're seeing people using Docker for their application deployments, like by a fairly wide margin. So as this slide is entitled, we've introduced this concept of app-centric Docker monitoring. We're not just kind of throwing Docker metrics at you. We're showing you Docker metrics in the context of your application. We do some direct Docker monitoring as well, where we think it's relevant for debugging real problems. But we definitely paired things or scope things to kind of real use cases that we've encountered and that like we were hearing customers encountering as well. So really quickly before we get into the demo, I just want to kind of set some context here. What does Docker mean for APM? And kind of the old world without Docker, and this is kind of New Relic boiled down to 2 squares and 2 lines. New Relic has like the bread and butter product of APM, which is actually instrumenting your application live in production, showing you detailed insight into how your application's performing, like what your response times and throughput are. And then we have the servers product, which is basically showing you how the infrastructure that application is running on is doing. So very comparable to Top in Linux or Process Explorer in Windows. It's basically showing you kind of machine-wide metrics. Here's your CPU, your memory, here's what processes are running on the host, so you can find out noisy neighbor problems. So when you introduce, sorry, before I go on, one of the really powerful parts of New Relic is that we have very, very strong edges between these 2 individual nodes. So from the application, you can easily traverse in our UI to the server, and from the server, you can jump back to the application. So when we introduced Docker, or when Docker was introduced to the mix, essentially that connection got broken. Like it broke up this very happy marriage where from the application's perspective, the Docker container is the server. Because again, it's emulating the operating system. Your application has no awareness that it's running inside of a container. So the connection down to your server is actually broken. So that's one of the things that was kind of in that category of something that we wanted to fix, that we knew customers were experiencing, that wasn't some shim side solution, but was really a part of the New Relic APM product. And just getting even more concrete than that, just kind of taking you through like what the world was before we did our fix. So from the APM to servers connection, this is kind of what you'd see at the bottom of our APM product, which represents like an individual application instance. You'd be able to see all of the servers that that application was running on. So you can see here there's 3 servers, but you can see there's something kind of weird here, that this is just a random GUID name, and this looks a lot like a short container ID, and it actually is. So when you installed your application on Docker with New Relic instrumenting it, the APM product actually couldn't differentiate between the host it was running on and the container it was running inside of. So what you'd see was these containers basically appearing as if they were servers in our UI, and you couldn't click them, you couldn't traverse back and forth between the APM and the servers. Conversely, from the servers to the application view, so again, you're looking at an individual server, we have this little thing that we call the related apps view, which shows you all of the applications that are running on that server. And basically, when you were running inside of Docker, for that exact same picture that I showed on the last slide, you basically got no awareness of what applications were actually running on that server. So with that, we'll jump into the fun part, which is the actual demo. So I'm going to jump actually into Chrome here, and I'm doing this all live, so demo gods be with me. So what I'm showing you here is actually a real customer of ours that has agreed to let us use their data for demo purposes. And they actually did a use case study with us as well that you can check out at newrelic.com/docker, which I highly recommend. But what you're seeing here is basically our APM overview page. So you can see there's kind of a lot of different things going on here. Like you can delve very deep into your application, but we're just going to focus on the Docker-specific features right now. So we're looking at this application running across all of the different machines. So like, this might be representing like these graphs, 4 different instances across, 4 different servers. So one of the first thing that's kind of Docker related is all of these graphs that you're seeing right now, I said, are representing an aggregate. If you actually click this drop down up here, you can actually see these are the individual container instances. You can actually click any one of these and scope all of these views and all of this data down to an individual container view. So if you're trying to debug, like some anomalous container, or you think that like one's having a problem and you want to debug why, you can scope our views down to just that individual container and see what metrics were reported from the application running just on that host. So going down to the bottom here, like this is that exact same view that I was just talking about from the apps to the servers view that shows you for this application, here is all of the servers that it's actually running on. So you can see here, it's running on 2 separate servers, Mesos Node 3 and Mesos Node 5. And on Mesos Node 3, there's 1 container instance. And here's kind of all the metrics for just that 1 container instance. And on Mesos Node 5, there's actually 2 container instances. And so this kind of gives you, at a glance, you can say, if I take Mesos Node 5 out of rotation, maybe you have to do some maintenance on it, maybe it's having a problem, how is that going to affect my application? Like, it's like, what kind of capacity am I going to lose? Am I going to have adequate redundancy? Like, am I prepared to handle the load that I need to? So it's really awesome to see that kind of right off the bat. So now we'll actually jump into one of those individual nodes. This one's Mesos Node 3 in staging. And I'm showing you now, this is that related apps view, which is showing me all of the applications that are actually running on this individual server. So you can see here, there's this app legacy staging. This one's actually running directly on the bare metal. But then there's this services settings staging. And this one actually has a container instance associated with it. So now I can actually see for my individual applications, like how many container instances do I actually have on this host. So it looks like all of the applications that are running on this one only have 1 container instance associated with them. But again, it's the exact same kind of problem that we're solving, which is now an ops guy can just log into New Relic, look at a server, and say, hey, I know I have to do maintenance on this server. What is it going to affect? At a glance, without having to worry about, it's like, logging into the machine and trying to like keep track of all the things. Like he can just say, oh, I know that like I need to reach out to the Concur service team, or they can actually click into that and see like, do I have adequate redundancy across the other hosts? So again, really, really useful things, and it's baked into our core New Relic feature set. So that was something that like we've realized, a lot of people are kind of shirking on. One of that's kind of like in the vein of things of fixing the things that kind of like the new Docker abstractions like kind of made more difficult in New Relic. But in addition, I mentioned that we did actually do some Docker monitoring specific work as well. So with that, you can see that for an individual server, there's also this Docker tab here. And if you click in on that Docker tab, you basically get this view. And what you see is all of your Docker images that are actually running on this host. And again, gets into, we didn't want to show like Docker GUIDs or IDs or something that like it's like where you have to like actually log into the machine that actually get context around it. We roll things up by images because if you follow the Docker naming conventions that are recommended, in general, your image name has all the context behind what the container is actually doing. So you can see in this case, it's the company Modus. The ping federate engine is the specific application that this container, that the containers are running in, and then master 2. So I assume this is version 2 of that application. But you can see I can hover over that individual instance. There's 1 container running on this host that is of that image type. If I had multiple containers, it would basically just increase that count, and all of the metrics that you're seeing here would be averaged out. We're also not showing you kind of like a blanket view of every single CPU consumer and every single memory consumer, but we're showing you the top 5 for CPU and memory because that's likely what you care about. You care about finding the ones that are making the biggest impact on your machine. So from this view, like I can switch it from memory to CPU, and like we have this Modus Solar version 47. And like I was kind of going through and just trying to see if I could find anything. And again, this is a real customer with real data. And I actually kind of realized that he has this application out there that's sitting at 1.86 gigabytes of memory. And I thought that's interesting for a Docker container. So this is looking at the data over a 3-day window. We can see here that about 3 days ago, the application was sitting at 1.8 gigabytes. but now this container has been slowly increasing all the way to 1.9 now. So it actually looks like there's a real memory leak in production or in staging right now for this container. So like, that's kind of the debugging process that you can go through. You can do that for CPU and memory. You can click on any one of these individual instances and get more data from a drill down view. Again, all very contextually relevant, all solving real problems that we had. So that's kind of what we've done from the Docker monitoring perspective. And one of the really cool things that comes out of this view, like you can see down here, the top 5 memory consumers, like there's kind of all these little spikes and like random cutoffs and everything like that. It actually really helps you tell the story of what was running on that host when. So you can see this Solar process has been consistently running on this host forever, the last 3 days at least. But then there's this Modus user portal process that basically was running and then went away. So what that likely means is like that container was switched to a different host, or maybe the application isn't being run anymore, maybe it was an experiment or it was decommissioned. But you can actually now see it's like kind of what was actually on the host when, what affected what. Like do I have adequate resources on the host to add more containers? One cool thing too is that you can actually click and you can kind of drop these things down. You can look at individual processes if you're not cared about these kind of short-lived anomalies. And just one more thing that you kind of get out of there is this is actually from our real production data for New Relic. We actually we created this feature, and then we looked at the view a few days later, and we saw this view. And what you can see here is really, really impressive, and I'm super excited about it, is you can see we have this New Relic Insights project, and as Andrew mentioned, that's kind of one of our core products that we have. So there's this. This is just a Git hash of that release of the project. That's what they use for their Docker tag. So you can see that that was running, and then it disappeared. But then this new insights with a different hash basically picked up at the exact same time. And you can see right here, there's this really cool overlap where there's a period of time where they're both running and they're kind of stacked on top of each other. So that's actually your rolling deploy. That's we had the new version of Insight slowly rolling out across a couple of the machines, but we were still running the old version at the same time. So you can actually watch to make sure successfully my rolling deploy has actually worked. I've decommissioned the old service properly. The new service has taken the load. It's a really awesome way to actually live watch how your Docker containers are actually going out onto your host. We also have a pretty big spike here with our metric time slice service, which we need to look into. So that's the demo. And with that, we'll jump back into the slides here. Sorry, Andrew, do you want to give me your marketing foo quickly on how I...
Here, let me go.
Boom. I was getting there. So as Andrew already mentioned as well, to actually try out the Docker stuff is, first off, free, most importantly. But second, very, very low friction. It's basically just a daemon process that runs on your host. So to try this out, see if it provides value for you. It's a very low investment, literally a matter of minutes. If you don't like it, it's pretty easy to just uninstall if it's not providing the value that you think it will, or that we hope it will. But really quickly, kind of the prerequisites that you need to actually run it are all of the existing Linux server monitoring prerequisites, which are basically you have Linux, which is a pretty easy story. Again, it's just a daemon process running on the host. A 1.4 plus install of Docker. That's kind of what we officially support. We actually have tried on older versions of Docker. We recommend 1.4 plus because there's a pretty big security patch that went out there, so just for kind of awareness' sake. And it must be a 64-bit host, and that's actually not a requirement on our side. That's actually a Docker requirement. Docker does not run on 32-bit machines. So again, these prerequisites are pretty relaxed, and the install steps are even easier. Install Linux server monitoring. It's literally you just do an apt-get install, the few copy-pasted commands. Really easy. A matter of minutes to get this thing on your Docker host to see if there's any value coming out of it. You have to grant access to the server monitoring process, access to your Docker group, your Linux Docker group, so it can actually pull the Docker data, and then just enjoy the data. Again, it really is that simple. It's actually so simple, and Andrew, as a very astute marketing guy, recommended against this because he's like, hey, don't create a hashtag because if it doesn't work out, we're going to look like we have egg on our face. But why not? So I actually we created this hashtag, nrfastestDocker, go off, try to install the server monitoring product. You know, like tweet us at or with this hashtag of how long it actually took you to get on your thing. Whoever got it out there the fastest, like we'll get some prize out to you, and we'll verify that you actually used it too. So one final thing before we get into the Q&A is I want to kind of talk about the little stinkers. And I've shamelessly put a very adorable dog on this picture to kind of distract you from all the content of the slide. But what I'm going to be talking about here is kind of just preempting some of the questions that, like, you know, it's like we've been very engaged with customers. Like, we know what, you know, like kind of our surface area is right now and where we want to expand to, and kind of just let you know what we're already thinking about for kind of our future versions of Docker monitoring. So first off, containers as first-class nodes. When this webinar first started, there was actually a question that's directly relevant to this one. Basically, right now, containers are basically accenting server and APM data to a large extent. We know that people actually want to be able to view their containers across like all of their clusters, and they want to see containers as first-class entities that they can search by name, they can see the metadata, they can do tags and labels. You know, it's like really just make containers a first-class entity inside of New Relic. So better swarm management associated with that, so it's easier to kind of go across machine, more metadata around containers. So this addresses the question that came in for the webinar, which is like, can you expose the name? Like this is exactly kind of focusing on that problem. CoreOS support is a really big one for us. We've taken a couple stabs at it. We do have kind of an image up on Docker Hub right now that works on CoreOS, but there's a couple caveats, like, you know, like we're not comfortable really calling it production quality yet. It's kind of in an early alpha state. We have a lot of customers that have been using it successfully, so feel free to try it out, but, you know, just kind of caveat mTOR on that one. And just better alerting. Like, you know, it's like now that we have this massive corpus of data, we know people actually want to be able to set up their alerts around it, because you don't want to be checking New Relic every day. That's not like the way that our product is meant to be built. It's meant to be like when something goes wrong, we provide you a delightful experience to figure out what it is and get to the bottom of that quickly. So with that, I'm going to hand it back to Andrew.
All right, thanks a lot, Adam. And while I walk through this, just a reminder that if you guys have any questions, please enter them in the questions section of the GoToWebinar, and we will go through those and get some answers. So just to wrap things up on next steps and how you can get going on monitoring your applications inside your containers. New Relic does have a 14-day free trial that you can get going on the entire platform kind of quickly and easily. As we mentioned, servers and by extension Docker monitoring is also free. That you can, you know, with no time frame attached to it. Very easy to get going and start to do your monitoring. Also, if you are one of the lucky folks who will be winning one of the physical Docker books, we will be sending that to you. But for those of you who are not, there is a free access to the ebook, which you can find on newrelic.com/docker-book. And there you can sign up and just download that. It's actually written by two folks who work here at New Relic. So we may be exposing you guys to those engineers at some point in the near future. And one other thing I wanted to just mention that you know, Adam didn't just fall on that cardboard box analogy. His office is just full of Tupperware and shoe boxes. He's been working on that for months. So please consider you know, the importance of a great analogy and how hard Adam worked on that. So with that, we'd be happy to answer any questions you guys have. Also attached our Twitter handles here if you guys want to fire off any questions to us. Probably Adam would be more appropriate for the technical questions, and then I can answer any slide and marketing stuff. And I do not drive a Lamborghini, Adam.
Not yet.
I have a bus pass. So yeah, why don't we take a look? Are any good questions you want to jump into, Adam?
Yeah. So we have one. Actually, we have a couple questions that are somewhat related here about volumes and processes. So the short answer is, you know, like we've kind of already hit on this a bit. Like, you know, it's like we know that there are future versions of this Docker, like where Docker feels like a more kind of first class, or containers feel like a more first class setting inside of the Relic. And definitely something like, you know, like the volumes and all of that kind of associated with it is something that we're going to be focusing on. But one thing I did want to show First off, like it's important to bear in mind that Docker actually, like I mentioned earlier, a container is just a process running on the host. So when you have a process inside of a container, it's basically just another forked process on the host. So we do have this processes tab, and like the internet's been somewhat cooperative today, but if we can click into this, you'll basically see the exact same view that we have here for Docker containers, but for actual processes. So you can see there's 8 instances of Java processes running. So what this means is any process that you have running inside of a container will be exposed through this processes view as well. It's the same thing, like we actually have the disk view as well, so like that'll show you kind of like, like the disk utilization and like what volumes you actually have associated with the machine. Unfortunately, it doesn't give you a good semblance of what volumes you actually have mounted inside of your Docker container, which would be a future iteration. But it does at least kind of give you that rough outline of like what the machine-wide metrics are, and it will at least be indicative of, is there a problem? So WebSphere specific APM, or do you recommend a Java module for monitoring logs inside of a Docker image? So one of the really important things to think about as well, the short summary of the question is basically about APM and instrumentation and Docker. And the short answer is it doesn't matter at all. Like your APM process never changes with New Relic. Like it's we are a compile time or a build time dependency. So like it's like when you're actually like developing your Java application, you would basically just add the jar at that point, and that would do all of the instrumentation of your application. And you don't think about us when you're deploying. You don't think about us like or turning something on or doing any additional work at any point. Like APM just kind of works out of the gate. It's an extremely convenient experience to actually get that stuff out there. And the Docker monitoring solution actually runs entirely at the Docker host level. So you actually have to install server monitoring, and it has to adhere to like the Docker directory structure. But other than that, like you're not doing anything in particular special for your Docker monitoring or your APM when Docker is in the middle with New Relic. So when Docker containers disappear or are removed, does the New Relic API SDK allow us to remove them similar to old New Relic server instances? Basically, because right now Docker containers and images are not first-class entities, like they're not appearing like kind of on their own list view. There is no gray container problem. Basically, like you have your time window up at the top here that scopes to the view that you're looking at, and if the container wasn't running during that time window, it basically just falls off the back end there, so you no longer like will see that data. So like basically we automatically take care of just getting rid of that data. When we go to the Docker's first class or containers as first class entities, that will be something that like we'll be bearing in mind very closely because we know the transient and ephemeral nature of Docker containers. Since containers are light, we'll probably launch them in bulk. So my server tab will be flooded with those containers. Also, what would be a good alerting system for large deployments? For example, can I get an alert on a specific process? So a couple of different questions here. First off, so I've talked predominantly about like where I've said like the industry kind of is right now, which is very much centered around Docker containers as application VM replacements. There's a whole nother use case that actually is like gaining a lot of traction, and we use it in-house as well, which is using Docker more as just kind of a process isolator. Like it's like you're literally just spinning like Docker containers up for a matter of a second to do some like very minute task, and then they disappear. So with that, like this Docker view does help. It's like one thing. Already going to condense the data down, but it's only going to show you the top 20 CPU and the top 20 memory. So you're not going to be seeing kind of every single container, and like it won't be flooded. And if you're not using New Relic APM, where the containers predominantly are going to be more longer running, you're not actually going to run into that kind of ephemeral instance problem. So the server tab and the application tab, those first two features that I showed during the demo, actually won't be relevant in that kind of more transient Docker usage.
So Adam, real quick time check. Folks, we've reached kind of the top of the hour here, but just want to let you know we're going to plow through these questions. So if you'd like to stick on the call, you're more than welcome to. And also, the webinar is being recorded, so you'll be able to access this later. But like I said, if you want to stick around, we'll go through these questions.
And as soon as I finish these questions, I'm road tripping to Vegas, so I'm not rushed at all. All right, so let's see. Where were we on the last one? You lost my place, Andrew. All right, let's just start from the top. Name, volumes, WebSphere. Why do containers process in that view? Aren't they supposed to be isolated? So the short answer is containers are isolated from one another. So one container doesn't have access to like host level resources. It doesn't unless you mount them explicitly. So containers are basically like kind of like if you think about a tree view, or some hierarchy. Like your server's up at the top, and then the container is a node off of that server, and then the container can see everything kind of below it inside the container, but it can't see above it. So why the processes are appearing inside of that processes view, even though that they're inside of the container, is because we do our monitoring actually at the server level. So the server can see all of the containers, all of the kind of it can introspect into the individual containers, and those processes ultimately are just running directly on the host themselves. So that is why you see the processes. Containers are isolated, but the server still has visibility. Would probably interesting to reference the container from the process metrics. Absolutely. Sorry, I don't know if I mumbled that. They basically said it'd be interesting to reference the containers from the process metrics. So it's like when you see those processes, you can actually like correlate it to what container they're running into. That is absolutely something that we've thought about. Again, we have a laundry list of like really awesome things that like would be really helpful for future versions. Do you keep maximum memory and CPU per container used so this info, so the scheduler, Mesos, Kubernetes can be given accurate ceilings for memory and CPU allocations? Unfortunately, no. The way that we set up the data right now is we basically just send up kind of the raw snapshot for the given time. You can extend your time window, kind of from 30 minutes all the way to 3 months. If you're looking at it on a smaller scale, you're going to get about 1 minute granularity, and that unfortunately, like if you have a big spike for like less than 30 seconds or something like that, we pull every 20 seconds. We will pull that data, or we will actually catch that, and that will be a part of the data that we do. But because our granularity is not that small, there are still like spikes that could be really anomalous that we may miss. In general, though, with like kind of expected usage, it's unlikely that you're probably going to run into a lot of those scenarios because like you'll either have the steady state, or which will be somewhere near, or if you have a spike, it's probably a problem when you're thinking about the way that you use Docker. Is it possible to see CPU or RAM via container ID? Is it possible to extract specific info related to containers through insights? So 2 questions there. For seeing based on container ID, if you have APM as well as the Docker monitoring solution, you can see here, this is the container ID, and you can scope all of your APM, your application-specific metrics, down to the Docker container. And down here, like when we're looking at that kind of application view, we can see for this container 316A4, like here's the CPU and the memory utilization, and you can kind of click in and get the historical views there. So if you're using it for kind of that app server scenario, yes, you can see the CPU and RAM, but we've rolled everything up to the image for semantic reasons. A little bit of how the sausage was made there. Actually, we decided to do the rollups to image because first off, we wanted to actually be useful information, but we weren't quite sure what the ephemeral nature of Docker containers was actually going to look like in production in terms of load and scale and like what use cases were actually going to be, and we want to make sure we were actually going to provide like useful data. So now that we have a better sense of that, that's definitely back on the table. Like a container level visibility, which is what we're calling the first class containers. Specific to grab it from insights. So we do have our data out API, and all these metrics are basically just server metrics. So you can extract this data from our data out API and actually send it up to insights and do analytics on it there. Do you have plans to correlate metrics between Docker containers like you do between apps when one instrumented web app talks to another? It's something that like we've talked about before. Like in all honesty, like we haven't really kind of like put any definitive use cases behind it. Uh, this kind of actually segues greatly into we have the New Relic forums, discuss.newrelic.com, and there's the whole Docker section under the server monitoring product. And we are very actively, like as the product team and the engineers, scouring that data regularly, like looking for people to tell us like what are the use cases that are important to you, what are the types of data that you actually need, like what are we missing, what do you like about what we have. So like I highly encourage you get onto the forum. Like again, like it's going to go directly to us as the team, and kind of just let us know like it's like what your use case behind the container correlation scenarios would be. Will any communication abstraction between containers, for example, using Kubernetes, affect the plugin communication of the host C groups or stats? How you're getting the stats? In general, we haven't encountered anything like that. Like it's like there's a pretty vast landscape of different tools. It's like we have a lot of people that are using Mesos and Kubernetes and CoreOS, and like there's a lot of different variants of how people are actually running and managing Docker. How we actually get our data is we use the Docker API, so that's why you're granting access to the Docker group to the server process. So the server process basically scrapes that API, gets a list of all of the Docker containers, and then goes directly to the C groups and parses that data out itself. So if your C groups is moved to a different folder, you'll have to change a configuration parameter, or if there's like some abstraction in there, that definitely could break us because like we're directly scraping the C group and parsing it ourselves. What do you think about Docker everything quote? Is there any stuff that need persistence like database that you would not recommend using Docker? I would not venture to make any recommendations about Docker usage. It's like I've realized that a lot of people are doing a lot of things that I wouldn't have expected Docker to be used for, and they're doing it pretty successfully, and they're pretty happy with the results. In general, I know we don't do databases inside of Docker containers. Like we basically just use it for app deployments and process isolation. But I know a lot of customers that we've engaged with actually have done that successfully. So I would say give it a shot. Is it easy to install and configure Docker for existing application? Actually, it's dead simple because you asked about for applications. Basically, if you're already a New Relic customer and you're already using APM, nothing changes from your APM perspective. Basically APM doesn't need an additional configuration parameter. You don't need to deploy anything new. All of this is going to be retroactive for your application deployments. For basically all of the data gathering and like the important parts of our server monitoring or our Docker monitoring product are in our server monitoring product. So once you set up server monitoring on the host, all of these Docker features just light up for you. Is it possible to get Docker monitoring running on AWS ECS? So the short answer for that one is no, but we're looking into it. So we know that we've talked to people at Amazon that work on the ECS team. They basically told us it's just a Docker daemon, that there's nothing special going on there. But when we run our server monitoring product, it actually doesn't gather the metrics properly. So we need to figure out kind of where the delta is and what's actually causing problems there. So yes, currently you cannot use our solution with the ECS. But again, happy to crowdsource from the community. We know we've had a lot of people on the forums have tried it out and kind of given us, very helpful information as to what their experience was like. We'd be very thankful and grateful for anything that you guys came up with. Are the laundry list available somewhere for enterprise customers? Want to see which features would be available in Q4 2015, for example? So no, not currently. Always feel free, we're a pretty open company. Reach out to your sales or your TAM and work through them, and they can proxy through what's feasible for the individual product teams. With what frequency might you be releasing iterative updates? Not asking for a promise, just curious how quickly we might see items from the laundry list finished and made available. Yeah, so I have my PM actively waving his arms in an X fashion. So I cannot discuss that. Yeah, sorry. I previously haven't used APM, but have enabled Docker monitoring for servers. My APM page remains blank initial state. If I'm only using Docker, how do Docker stuff show up on the APM page like you demoed? So if you're not using APM, like you won't see any Docker stats on the APM page. Basically, this solution is very APM centric for the APM page, obviously. So you'd actually have to be using the APM product to take advantage of that feature set. That said, the Docker tab on the servers page and like all of the server metrics that you get are kind of out of the gate, no additional dependencies. You'll get that for free. Is Docker for Windows supported? .NET? No. So Windows is still kind of, at least to my understanding, last time I checked in on this, Microsoft announced that they were doing something Docker related, but I think it was still in development. Our solution, again, I mentioned kind of one of the prerequisites, it's completely predicated on a Linux version of Docker. So that means boot to Docker for OS X or Windows also will not work. Do you know what other industry tools for Docker container management are becoming common? So Key.io, for example. I know there's a lot of different Docker registries. There's Key and Docker Hub, and I kind of like open ways that you can create your own. Like there's Kubernetes and Mesos and CoreOS, and like there's a lot of different tooling out there. So in terms of what we use internally, we've used Key, we kind of have some home-baked tools surrounding it because, again, we started pretty early in the Docker game, so we ended up kind of baking things or making our own things before something was actually available for us. If you're interested in kind of hearing more, like reach out to me on Twitter, or definitely like Sean or like Andrew mentioned, like the people who literally wrote the book on Docker are our site engineering folks, and they're definitely going to be the best bet to like kind of the down and dirty, like how do you manage this stuff. So like we can definitely put you in touch with them, and they're more than happy to kind of talk about this stuff at length. Given that ECS is problematic for AWS Elastic Beanstalk, non-multi-container deployments, they don't use ECS, does Docker monitoring work normally? So one of the things that we're not sure of is the problem the ECS, product specifically, or is it something to do with Amazon Linux, or kind of like where the problem actually is? We know that we work on Debian-based systems like Ubuntu and Red Hat-based systems like CentOS. We've tried on a couple different ones as well that I'm not going to outright mention, but if the problem is the ECS product, actually, the short answer to your thing is if you're using AWS Elastic Beanstalk, you should have direct access to the VM itself. We don't really differentiate between like where it's running. Like all that we care about is that C group data is there. So it should work perfectly fine if you're not using Amazon Linux, if that's the problem, which it may not be, or ECS. My server says that it has no apps running, and my app says it has no servers. Did I configure something wrong? No. That's a very interesting one that I would love to follow up offline with you on. In general, that's indicative of like your application not running for a specific time window, or the server, maybe the application was down. Maybe you're looking at a 30-minute window, and there's some problem going on there. It's hard to actually kind of deduce that through just this, but reach out to us and we'll help you figure out what the problem is there. So I think that's the end of our questions list. So if anybody has anything else, or if I missed anything, feel free to ping us now. Or forever hold your peace. All right. Thank you so much for attending our webinar. We look forward to doing many more with you. And again, what's the min version of server monitoring that includes the Docker features? It's 2.01.124, I believe. Wow. Thanks, Brain. So that should be the latest version. The CoreOS image I mentioned on Docker Hub as well should have that latest version deployed there as well. Vegas, thanks. Thank you, Todd. You're a good man. Awesome. Okay. Well, oh yeah, sorry. And the last call to action, again, don't forget about the NR fastest Docker hashtag, because I really want to shove that in Andrew's face. And in addition, like, it's like, please reach out to us on the forums. Like, like this product, we want to actually be shaped by real customer feedback and to solve real problems. We don't want to just go off into a black hole and come out with like, hey, here's something that you guys all want, and then kind of realize that that's not true. So like, like the more engaged you are, like, the real problems that you're facing, like, whether it's stuff that we've done wrong so far, or like, broken features or bugs, or like, it's like just great ideas. Like, we want to hear it all. Discuss.newrelic.com. So we look forward to more of these in the future, and thank you all again.